Hi, everyone. Thanks for joining us. I know this is a really busy time of this semester, so it's nice to see you all. My name is Paige Johnston, and I am the Associate Director of Public Programs here at the GSD. I want to begin by acknowledging that the Harvard Graduate School of Design is located on the traditional and ancestral land of the Massachusetts, the original inhabitants of what is now known as Boston and Cambridge. We pay respect to the people of the Massachusetts tribe, past, present, and future, and honor the land itself, which remains sacred to the Massachusetts people. The school also recognizes the work of the Harvard University Native American program in cultivating the relationships that led to the creation of this acknowledgement. A quick reminder that we have live captioning for those of you watching the live stream. Just click the button at the bottom of the live stream window that says closed captioning. I also want to quickly invite you to two programs that we have coming up next week. On Monday, November 6th, Lena Gottmay, founder of the Paris-based studio Lena Gottmay Architecture, will discuss her approaches to practice in a lecture entitled Living in Symbiosis, an Archaeology of the Future. So that's on Monday. And then on Thursday, November 9th, architect and theorist Pier Vittorio Orelli, one of the co-founders of Dogma, he will present research on the longhouse, the linear, long, and narrow habitation typology that existed and still exists in many places across the world, including South America, Europe, and of course, North America. Now I'll hand it over to Gary Hilderbrand, who will introduce today's speaker. Thank you.
Thank you, Paige. Welcome, everyone. Thanks for being here. She's right about it being a busy time. Mid-reviews this week. This is the Kiley lecture, and I want to say that it's supported by the Daniel Urban Kiley Fund in the school. The fellowship is awarded annually to an emerging designer whose works articulate the potential for landscape as the medium of design in the public realm. And it's intended to recognize and foster, sorry, that is a duplicate. We've had 7 or 8 Kiley Fellows, including Daniel Choi, Seth Denizen, Paula Sturla, Montserrat Bonvehi-Rosic, you know her as Tat, and Fionn Byrne, and our current Kiley teaching fellow is with us today, Kira Klingen. It's a great pleasure to introduce Tomás for this lecture. He came to us 2 years ago, and we liked him so much we kept him around. And it's been my personal privilege, really, to teach alongside Tomás in Core 1 and Core 2. And I have to say that he is a very diligent, very careful, considered teacher whose guidance for the students is really very good, very special. Tomás is also a professor and co-director for the Center for Ecology, Landscape, and Urbanism of the Design Lab at the Adolfo Ibáñez University in Santiago, and he's a founding partner at PAUR with Sophia Armanet, who's here also today. Welcome, Sophia. Tomás has a background in architecture, but also he has his MLA from the GSD. And so it was really such a great pleasure to welcome him back here after he finished in 2012, I think, right? And he came back and taught an option studio, and at that point we said, well, how else are we going to get him back here? And get Sophia, too. You know, their work is on the public realm landscape in a place where the field of landscape architecture is, let's say, vague and not supported institutionally, as it were. And so it's really to their credit that they have gotten recognition for a kind of work that we take for granted in the U.S., but not really in Latin America. So the great recognitions, including the 2023 Venice Biennale, the 2006 Architecture Biennale of Chile, many other awards, National Exhibition Award of the Architectural Biennial of Santiago in 2008, South-South Professional Award of the XX Architectural Biennale of Chile in 2017. It goes on and on. I think this work is getting recognized, even though, as I say, there isn't a strong framework for recognizing that kind of work. A tribute to this great designer and teacher. Welcome, Tomás.
Thank you all. Thank you, Gary, and all that you are presented today here. It's a great pleasure to give this talk. But first, I would like to thank not just Gary, but Anita and all the people that supported me to come here for this gifted time of being among interested and talented people, faculty and students, I must say, that I admire, and for forcing me of trying to see their clarity and confidence in the things I teach and practice, both links in research. It's been a great experience and has reinforced my practitioner profile in academia, allowing me to see and intend to organize a mode of operatic practice. I've seen myself sometimes a little bit stochastic and entropic, sometimes randomly organized and generating energy that is not capable of producing movement, I would say. So the time here is a great opportunity to think and clarify me, always intended to be, as the fellowship states, someone who contributes toward a work in the design public realm. The lecture today is called Hydraulic Geographies, Atlas of the Urban Water in the Andean region. And first I would say why the title. I think why Hydraulic Geographies is kind of a complicated title. But geography is the study of places and the relationship between people and their environment. Hydraulics, in the other sense, is a mechanical function that operates through the force of liquid pressure. And the purpose of hydraulics is to create motion or force. It is a power force, I would say, and I would like to call it a landscape agency. So this is a study, this lecture is a study of relation between people, their environment, and the shaping force of water in the adaptation of our urban landscape in the context of climate change. Latin America has 31% of the world's water resources. The development of a drinking water coverage that reaches 94% compared to developing countries. However, 37 million people still do not have access to water, and 100 million lacks access to sanitation. Chile, for its part, has 99% of drinking water coverage. However, a large amount of its territory is in a continental zone that will be strongly affected by the future consequences of climate change, both because droughts and floods are a product of receding of the Andean glaciers and the evolution of projected precipitation patterns. Thus, climate change will force the Andean region to rethink how they manage their water resources and the infrastructure that allows their management. Better collection, storage, and distribution system will be essential when promoting ecologically and socially sustainable development. It is necessary to have an integrated view of the resources of the infrastructure that manage them, thinking about the multiple dimensions to which this could be cohesively respond. The water cycle in general, this is an image of the old water cycle diagram. From an early age, we are taught that water defines a cycle of changes in a state and flow, from the ocean and its evaporations to the forming of clouds by condensations and rivers through precipitation. This water cycle, whose diagram has been how children and adults define realities, has recently been updated. In October 2022, the US Geological Survey published a new diagram after 20 years, including humans as protagonists of a prevailing cultural assumption that the water cycle was a natural one. The new diagram positions humans as the central factor of a new understanding and includes a multiscalar vision from the previous image, advancing from a single great cycle towards multiple cycles of varying scales. Agricultural, industrial, and domestic activities that are both consumptive and not consumptive, as well as infrastructures for the collection, accumulation, and distribution of water, allow us to recognize the system beyond a cycle, where vectors are not unidirectional, and on which new factors are to be considered. Water is not necessarily permanently flowing gravitationally, but being used once or several times, being transformed into energy, enabling extractive activities and allowing for changes in land use, recognizing that from a perspective of constant movement, we must now recognize that it is an anthropogenic cycle and that its representation is not necessarily balanced nor in volume or quality. Each activity that is part of the cycle is a factor of change. Agricultural fertilizers flow into rivers, deforestation drags sediment into riverbeds, affecting the habitats that depend on them. Our cities run on water and also generate gray water and black water. To this, we must add that the cycle will be increasingly affected by climate change, making it different each year, either stable or with sudden changes and increasingly greater consequences. This new diagram demands us to understand better that the need to respond to our current crisis systemically and to transform it into an opportunity for sustainability for our urban society. How can we understand that cycle in Latin America? And I feel that sometimes each landscape lecturer starts with this image. Nobody can avoid it, and nobody wants to avoid it. And this is the Geography des Plans Equinox Salt from A. Bonpland and Alexander von Humboldt in 1805. This is the second version of this diagram. The first one is like in 3 years before, that is just cutting part of the Chimborazo. The 2 years later, in 1807, there is a German version, the colorful one that we see, every publication, I guess. But this table shows, as you know, includes in the other two columns, atmospheric pressure, chemical composition of the air, temperatures, all related to height, and the Chimborazo is this volcano in Ecuador that defines the relation between all the plant species that lives there. What I think that is problematic to this, and for this lecture, is that this image doesn't show people nor urbanization. When I try to see it, and this is great about the Ramsey collection that now recognizes text. So you can find text in any plan or maps in the map library. That the Baccharis, for example, that we can find there is like a plant that is not so high. Actually, this Baccharis concava, or called bautro in common name, is something that we have in our landscape, in our patio in Santiago. So besides the great moment that we can spend looking for names, I think that we should advance to other drawings and other kind of sections. This is the section from Darwin in his trip to South America. That is interesting because it shows like a little bit like the urbanization that I was talking about. It shows like a section cut from Mendoza to Santiago. That is difficult to cut it, but it's trying to exemplify this geological section in the first two one. The last one is Copiapó, Coquimbo. But the first two is something that relates to production. It's not stated here, but if you know what are the two valleys that they are in the other both sides. From the Mendoza Valley, we have all the wineries of Malbec. In the other side, we have Carmener and Cabernet. So it's totally related to the geology of this space. Advancing to another, this other botanical geographical distribution of plants of 1850. From the notes of Alexander von Humboldt, but kind of represented by Alexander Keith Johnston. That is someone that I'm going to show a lot. We start recognizing that it's not just like about the species, it's about like what I said is about urbanization and the relation between glaciers or snow. There are different, Alexander Keith Johnston made a lot of sections in different places. He was working for that. And actually, it's very difficult to understand why. And my friends here from Spain will tell me why Tenerife is here. That is, doesn't have any snow, but it's like a sum of different definitions of these geographies. And when we see to the one that we have here in Los Andes, it's interesting that we are starting to recognize not just like the snow and the glaciers, but now we are kind of leaving aside a little bit of the species, and we are showing productive landscape. You know, we have like specimens here, like the pinus. We have and we have cities we can recognize. And see it here. We start recognizing like Potosí. We start having like the Chimborazo again here, and we have like City of Mexico and Quito. And the landscape portrayed there are much more productive in a way, you know. We move along that image and we go to see this distribution of plant by Arthur Humphrey and Alexander Keith Johnson again, 1855, that it has this relation with the production and the relation between glaciers, I would say, and that is my kind of position here, with the glaciers maybe and the different kind of peaks. You see in this one, we are recognizes the Andes, we recognize Quito, we recognize some of the summits in Chile. Like we have like the Aconcagua, the Aconcagua mountain there. We have some of the Volcanosorno there, and we relate that to the relation between what I would say water and the production of different grains. In this image of the Alp Glacier system from, again, Edward Forts and John de Carpentier in 1854, we are, again, looking to the summits, the different summits, and we see again that the Aconcagua appearing, the Aconcagua appearing there. We have like the Chimborazo again, and some glacier definitions. In this map, 1850, mountain change in South America by, again, Alexander Keith Johnson. I think it's interesting because now we start recognizing with these lines where the geographical accident, I would say, and we see the Andes, mostly the Andes that we're going to be talking today here very clearly. And when we go near to these maps that are great to recognize them, we understand that the Aconcagua that we have seen in other sections are here, 24,000 feet, you know. This like the Maipo River here, the different cities, Coquimbo, Limarí, the valleys, productive valleys. Is missing Santiago, but we can understand how the different kind of summits are related to certain cities there. And the same happened with this section of zoom in of what is going on in Ecuador with again the Chimborazo, Quito, and the related areas. 1856, and we are showing again North and South American physical maps, and that is interesting that when we start looking at certain details here, we know that Alexander Keith Johnston is including like a relation that is much more nuanced, I would say, but it's pretty interesting in a way that is now we don't have like this first image of the Chimborazo section, but we have like glacier. This is like a section of Bolivia, so Chimborazo is like thousands of kilometers north in Ecuador, but it's represented Chimborazo here, the volcano, Arequipa. We have the Lake Titicaca, Puno, you know, and in the other we have again the Chimborazo. We have Quito as a relation between these summits, the snow, and the cities that they are associated with them. And it's much more clear the relation here of this mountain change and the valleys that they are providing with water. So we have like the Chimborazo, if you can read it there, and we have like cities like Cuenca, is Quito there, and that goes on and goes on. What is, I think, important in all this kind of argument about this is like the relation that we have today is related to that in the relation between urbanization, the cities, the people, and the water that is coming from those really kind of tall glaciers. And I would call this second part of the lecture the geography of a near future threat. And I like this quote that is like a poet, Nicanor Parra, that said that we believe we are a country, but the truth is that we are just a landscape. And I guess that is pretty clear when we show like an image of Santiago. Santiago is a capital city of Chile. That 8 million people lives here. It's in the datum of around 600 meters above sea level, above the sea level. But this almost looks like a photomontage, but it's the reality. We have like the Andes just on top of us. And we have certain things that are interesting, that the city goes until the datum 1000 because of a kind of a regulatory norm. You cannot build on top of that. So you have like a control line here that is 1,000 meters above the sea level that defines the city. And you have another line that is not clear because it's a movable line, that is the line of what we call the isotherm. The isotherm is the line that defines where the snow starts. And this is the Andes in between Chile and Argentina. When you fly from Santiago to Buenos Aires, it's like the kind of the amazing, but at the same time frightening image of the Andes that provides water to these valleys that we are looking here. This is similar to the valley that I showed you before of Quito. This is Santiago. It's like where the city is being developed. It's, I would say, almost a desert, if it is not because we have like the Andes here providing water to all this development of agricultural land. This is again Santiago. This is an aerial image showing the huge kind of Andes mountain change. And the way that the city is organized in the relation with the Andes is from these kind of ravines. There are ravines that they are kind of possible threats, And what I say possible threats, it is because the way that the relation between water and snow is being defined is by a concept that is called the isotherm. The isotherm is like the isotherm is like that contour line that I show you that defines where we are almost in 0 centigrades, and where from that line below you have rain, and from that line above you have snow. Sometimes that line goes down, to 800 to 600, and we have snow. But in Santiago, people play, all the kids, the school shutdowns, etc. The president talked about the snow, etc. 3 times in my life I've seen snow in Santiago. But the other that is like the threat that I'm talking about is like this isotherm sometimes go up. And in 2007, as you can see here, the average is 2,300 meters above sea level. But in 2017, that isotherm went to 3,300. And in 1993, it went almost to 4,000. What does it mean? This level is that the way in the moment that these lines start going up, you change the area, the basin of Santiago, and that basin means that you are receiving much more water, and the volume change. It's not like sometimes if you move the isotherm from 2,200 to 3,000, it's just 8 meters going up. You duplicate the area, the catchment area by 2, and you multiply the volume by 2.5. We need to say that the basin of the Santiago is about 4,500 kilometers, 1.1 million acres. It's like 1,700 square miles. And compared to Charles River, that is 310, it looks huge. So in normal days, you could have that. This is a very beautiful image of Santiago. Sometimes it's much more polluted, but in normal kind of years, you can have like almost like a stream going down here, and the base of the river sometimes is being used for bikers, pedestrians, etc. But in one of those events where the isotherm goes up, the river becomes this one, and this like almost is like the Andes coming down, I would say, well, the Andes is going to melt completely, but maybe that will take 2 million years. But it's like an erosion. It's not water that is clean. It's just a lot of stone, mud, etc. coming down. This happened in that kind of empty kind of river. This is the image, and the people just go there to see, again, the water running. Sometimes the river goes out of the and it starts invading kind of financial district like this one, or more in the foothills of the Andes, you see this kind of behavior. Why is this happening and why it is important? Because it has like many implications. I would say that this is a map that we did with the research that we're going. We are working since 2020. That is showing exactly where the glaciers are located. You see in these blue marks like the glaciers in South America, and you have like another scale here that is like the height where those glaciers are located, and a radius showing the volume that they cover, or the volume of the area that each of these glaciers has. So in Patagonia, you have like ice fields very long. They're very kind of low in height, sometimes around 1,000 meters above the sea. In Santiago, you have like one of those like around 3,000 to 4,000 meters above sea. And in the Andean region of Peru and Ecuador, the glaciers goes almost like around 5,000 meters above sea level. That is kind of important because this is all the water that melts during the summer are providing like a huge amount of volume of resources for people, just for agriculture terms, but at the same time for drinking water. But those glaciers are melting, and they're melting in a very fast pace. I think the projection, this is like just like a snapshot of the IDB, the Inter-American Development Bank reports. The glaciers are supposed to disappear in 100 years in this area. And this is something that we have seen since almost like 70 years ago. This is the Olivares Alpha Glacier that is in Chile, and it has lost 66% of the ice mass since 1953. Why I think that is important to mark that is because those glaciers are the ones that provide water for our reservoirs. The reservoirs are not in the city like the one that you find here in Cambridge or in Boston area. The reservoirs are located on top of the city. This is like a reservoir called El Yeso, one of the two main reservoirs of Santiago. And the problem when we try to understand this is that usually in normal patterns, the glaciers that is like a mix between frozen snow, rocks, and debris and material, that they are not melting completely every year, so they are starting to freeze, and they start creating like a eternal kind of massive piece of ice. In a normal year, they should have like an accumulation in winter times, and then this is where you have like the rivers with the rain running through the city, and then you have in the early months of the spring, you have like a snow melt, and then in the summer, the glaciers start providing water. So that is the reason why the rivers have water in the summer in all the Andean region. And the second is like usually there are two processes in glaciers. One is the accumulation that I told about, and the other is ablation, the net mass loss. There are years that some glaciers gain volume, others lost volume, but the problem is like in the average kind of accumulation of the past decades, there is like an annual net mass loss. This is an example of the glacier extent, the glacier area that has been changed, along the years. That in reality, this is happening in all the glaciers that are in the Andes change. In some years, sometimes you gain mass, as I said, but in general terms, all of them are starting to disappear. This is the same happening in another location in the world. This is the Himalayan glaciers, that they are they play the same role as the Andean glaciers, that they provide water during summer so the streams can continue and they can kind of sustain all that urbanizations that we saw in the first sections of Humboldt and Alexander Keith Johnston. So what this researcher has been trying to deal with this situation and trying to understand what is the water that is being provided, how the water has been managed, and how I would say we can recognize the use of that water and try to understand how to work with it and try to provide like solutions, or at least try to adapt these new cycles that we're going to be kind of suffering. So the research component of this lecture is called the emergence of the invisible water. And this atlas, or what I call an atlas of the urban water, starts with the problem of representing what is not evident, the infrastructural reality that has been invisible to both our social experience and our discipline of design, particularly in contexts like Latin America, where information is not readily open and easily accessible. And from that perspective, the research brings mapping approaches from the field of critical cartography for making maps active, allowing us to build new knowledge and define potential tools to promote social change. This is a cartography. I don't know if you can see it clearly, but it's like a sequence of different maps that we have been doing based on the information of the water cycle in Santiago. We see the glaciers here, located here. We see that lagoon that I show you, the Yeso reservoir here, the Maipo River here, and all this is a valley of Santiago. The different land use, as we almost can trace like a Patrick Geddes section, we can understand that there is like a very clear kind of sections here from where is the water being provided and what the land use that they are supported. We have like the city, the inhabitants, the fresh water drinking. We have the agricultural fields, etc. And we have like, as a very geographical section, we have like a contour line that is the isotherm, another contour line that is like where the water is being catched, another line that is where the water is being distributed, another contour line that is where the water is being treated, or the sewage plant. Some other maps showing almost the same. These are the purifying plants. We have like a lot of the infrastructure for the distribution of water defined as a kind of gravitational elements. Some of these points where the water is being contained for distribution are kind of semi-buried. Some others are elevated because of the pressure. When you try to distribute water in Santiago, you require at least 25 meters of water column, that is called. That is like what is the pressure of 1 meter of water kind of coming down. If you have like a 25 meters of column water, you can distribute water. So in these areas, you just need to decrease the pressure because you have like the Andes coming down with the water and that pressure. In this element, you need to build vertical towers to make, again, like the water have like a certain gravitational force to be distributed. Drinking water, again, I'm gonna move faster. The water cycle here, like showing the different pieces. The problem here is like even though that we can map clearly like how the water is being distributed in this cartography, there is one thing that is important to say, that Chile is the only country in the world that has this water privatized. Since 1981, in the constitution made in the dictatorship, the water is being defined as a social good, but at the same time, it's being defined as a market good. So you can buy the right of having water, and you can sell it, and you can trade with it. So that means that all the water that now is privatized in big companies or small companies, depending on where you look for it, defines that the water is something that you are not ensured to have it, and when you don't have it, you have very critical issues like this one. This is located near to Santiago in the region of Petorca, where you have like the big companies producing avocado and exporting avocado. An avocado is like, a fruit that requires a lot of water. And usually for a kilogram of avocado, you require 264 gallons of water. And usually you need to irrigate with 39 to 52 gallons per day per avocado tree. And in an hectare, in 1 hectare of a plantation that usually use a grid of 5 by 4 meters, you have 500 plants that require the fresh water of 1,000 people. That is a definition that's kind of interesting, because the government of Chile defines that for sanitation considerations, each people requires at least 100 liters per day. In Petorca, and this is the same region, so what we are looking here is the same region where a riverbed is already dry out and where 3,000 people live from the provision of water coming from trucks. And the trucks that brings that water sell that water in a price that is exuberant. Truck water sells 1 cubic meter of water in a range that goes from 3 to 20. That is insane. While the fresh water that is provided by companies in Santiago costs 25 cents per 1 cubic meter to 90. The difference is because in Santiago it's much cheaper than in Antofagasta. But the people that sell this water is the one that has the water rights. So the companies, the government buy the water from the people that have the water in that region and then sell it to people to ensure that they have like a provision for a daily drink. The problem with the water rights is something that is kind of difficult in Chile and in South America. That is the provision of information. When you try to get that information, everybody tells you that the information is free, and there are transparency laws that allow you to ask for that information. But in your email, you receive an Excel sheet with thousands of entries without kind of geocodes or locational codes to understand how you can specialize those water rights. And so we had to hire like a geomatic expert to try to translate this one and try to make the water rights appear. So these water rights that we have here are the water rights use. As I didn't tell before, but there are 2 types of water rights: so the consumptive and the non-consumptive. The consumptive, the people that use the water rights to use the water itself. The non-consumptive is the one that they use it for a process and then they return it, like an hydroelectric dam or energy generation company. These are different water rights. The superficial water rights, the big companies that provide and generate electricity here. The underground water rights, there are underground water rights and superficial ones. All the people that have rights to get water from the aquifer. And how that is being kind of defined like a map of different uses, And here we have like different the different uses of that water, that because it's a market good, you can just change it. But usually when you ask for a water right for certain activities, you need to keep that aligned with the production that you're doing. And this is like interesting in the way that the water rights define volume, that this is not a percentage of the water that we have, it's a volume. So usually what the water rights surpass for many times the water that is actually provided in the basin. I'm going to move a little bit faster here to understand, but there are different companies, and there are restriction tools because we have like a drought of 12 years now in the Valley of Santiago. So even though that you have water rights, the problem is that you don't have necessarily like the access to that water. So there are many areas in different parts of Santiago where the water is not anymore running, so you cannot make use of that effective kind of right. As Gary mentioned, in 2019 we started like doing like an option studio here that was called Social Operative Infrastructure, that was trying to kind of understand these big infrastructures that keep the water on top to create the gravitational force to distribute the water, and use these spaces to kind of transform in terms of the massive kind of array of points in the city that were more than 200, to provide like social uses or transform these spaces into social infrastructures. These are images of those different cases. We went to see some of the semi-buried or the elevated towers, like this one. And we have great projects, like some students from that, like trying to develop different versions of different uses for those water infrastructure in Santiago. This is Eugene, different Simone Scavi. I show it like as an example of what we were doing at that time. But the problem that I thought before, and that was maybe the change that I did for applying to the fellowship, it was like, I thought that instead of focusing on transforming operational infrastructure with urban programs, we better focus on adapting our urban spaces to be water infrastructure. And that is where I would like to kind of explain a little bit of what we have been doing in our practice at PAUR. That it has, like, for me, the paradox of abundance and scarcity, because we live in a desert almost in Santiago without considering the Andes. We have like a climate that is much more similar to Arizona. We have almost the same species, the 3 species that you can find in Arizona, like Palo Verde, Parkinsonia culeata, etc. So we are designing in this desert to be floodable. So at some point we're going to get so much amount of water that we need to adapt to that kind of floodable condition, but we are, to be honest, in a desert. And this is like the first kind of project that I want to show, that is like the Batuco Marsh Nature Sanctuary Master Plan that is in the northern part of Santiago, where we work in a place that is like a hotspot of biodiversity. And this is like the different birds patterns going here. We are here in Santiago, so the same birds migration patterns that we have from the Pacific coast, from California, etc., goes here every year. But there is no wetland at all. I think it's like a kind of I would say a dry desert, very flat, beautiful in certain sense, but with a lot of problems. This is the image of that wetland. This is kind of the image that we found when we started in this project 3 years ago. This is kind of vegetation that you found in that kind of in that floor, and in some patches of water, because we have like an interesting kind of condition of the ecosystem here that we portray in this image, and the boundaries, the very arbitrary boundaries, administrative boundaries of the site. That is a site of 300 hectares. We started kind of working not just like in the overall place, but trying to deal with certain situations like adjacencies, borders, trying to do transitions with the neighborhoods that they are living here. And among them, like, it was interesting to find out that, and maybe this relates to the first diagram of the USGS kind of new water cycle. It was like a sewage treatment plant that is called La Cadellada. That is one of the main actors that by law now has to provide 173 liters per second to the wetland. So that wetland that's supposed to be like a desert now is being filled with treated water that is not drinkable, and it has like a lot of nutrients too. So that is another issue that we're going to talk about. But we started working with the different conditions of adjacencies, how to understand maybe interventions. We were working from based on an action plan and a management plan from the Wildlife Conservation Society. We try to define programs, not as a constructive way, not as a kind of physical object, but programs as uses and programs as certain interventions, and how to deploy them in time. That deployment will define much more than as I say, as a building. It's more like a process of activation during the time, trying to understand that at that point there will be like a dry season with no water, and how we can start understanding that as a possibility to define all these kind of blossom conditions of the landscape. That it was like quite amazing. here some diagrams of different aspects of conservation, itineraries, programs, etc. But this is kind of interesting because it's like this site that is 300 hectares used to be like a subdivision for real estate development. So there are a lot of parcels here, and the master plan is defined in the, I would say, mosaic of these small parcels. And we were providing kind of consultants for the foundation that owns this site to define where to buy, what not to buy, etc., to provide the kind of the scheme or the framework for the master plan. Some transitions. So we were, as I said, we were not designing 300 kind of a 300 hectare surface, but we were defining almost transitions. And I think it's interesting because of what we have sometimes been thinking in the studio, with some students are here, that we define not with metrics, we don't define with measures, we define with elements of landscape that tries to create that boundaries. And sometimes we have like certain elements or objects to activate those places. Then we did some, we zoom in some areas, we try to define the different pieces of that. As I told you before, we were trying to define what to buy and not what to buy. This is like something that is already kind of registered in the municipality. So in order to do like this mosaic, you need to say, well, please buy these 3 ones so we can create an access, move this one. And this is insanely weird because it's like a lagoon, but it has to cool the sacks here, etc., in an abstract way. So, and we developed some of the kind of the scenarios for the foundation. And again, transects as a way to define transitions, that is not like necessary metric, but it's like to understand what happens when you have water, when you don't have water, how these elements that are existing there can organize your master plan. And the other element that I think is interesting is that we had to provide certain elements. This is a master plan that is here. It's a kind of a brick, pretty heavy brick that is like a work of almost 3 years. But we were convincing the client that they need to do something in order to create trust for the community. And we were thinking at the same moment that if we didn't want to kind of intervene the site, we should have like certain elements that they are movable. So we need to see like a site of 300 hectares, we need to have certain height. So we were almost thinking about this staircase of all airports, as a way to move these points and activate different areas kind of associated with nesting seasons, etc. And I show this because I think each project, they're almost trying to prototype something, to test something, to iterate something, even though that in some cases we get wrong and we need to kind of go back again. But this is what we did for that, and we implemented after 2 years one of the same viewpoints. This is like a fence that they're going to take out, but this is an ecological fence, they call it, as a way to prevent kind of free dogs or urban dogs in Santiago that they run freely in the city. And these are kind of some images now that this water treatment plant is providing water, and now we start looking certain changes in the landscape. And there are a lot of birds and people using this in a, I would say, appropriate way. Some images from before and after when the water came in, and some of the publication here, maybe our participation in this year Chilean Pavilion of the Venice Biennale. The second project of the water, related to water, I think this is interesting. It's called the Gabriel Palma Park. That is like a park that, besides being like an urban park in the peri-urban area of Santiago, it defines a buffer zone to kind of control the relation between all these buildings and the water that they could provide. And it has like certain interesting moves in the way the morphology of the site is being defined. So we got all the material from the excavations of the foundation of those buildings. We create certain profiles in order to define the drainage of the park and maybe this catchment area in case of of a flooding. And again, as the marsh that I just showed, we were trying to do certain prototypes and iterate. We were trying to provide like a great playground area for kids. We were looking for kind of Richter spill grade kind of playgrounds in Germany. But we need to say that reality in South America is totally different. This is a park that costs around $8 to $9 per square meter. So it's the only thing that you can do is like just almost to talk, and we talked with the person that it was doing like this fence and say, well, what we can do with very kind of fence style production. And they say, well, we can weld these pipes. We can buy it in 12 meters, and we can put a lot of them, and we create like this inside like a playground that is almost like 112 meters long. That is like has like a German, I would say, standard, because this would be forbidden here, but in Germany you can have like swings that they are almost, this is 373 meters high. And this is the area that I was talking about, like about how to start designing this park in order to be like a buffer zone with the buildings in terms of water and runoff conditions. With a runoff idea of, as I said before, almost like a desert. These are Parkinsonias. All these are kind of drought tolerant species. So when we choose species for parks, we always try to find species that they can resist almost a summer without rain and without irrigation sometimes. Actually, these buildings are they are buildings for like social housing apartments mixed with the normal apartments. It's been very successful in their implementation. This is a almost last project that I'm gonna show. Like this is like again in an area of Santiago where the standard is, I would say, not so good. It's like an urbanization that goes furiously in the last 20 years. These are kind of a norm that was created in the 90s. So any developer can define like a big macro lote, and they just need to provide the infrastructure for them. And one of the problems here is like this is like what is called like a expansive clay area. So the water doesn't infiltrate. So water runs in the surface, and you can have like huge problems with flooding. And at the same time, this is Lampa in the area. That is like one of the areas where a lot of informal settlements are being located. The project that we work is not an informal settlement, but it's in this context of kind of lack of qualities of the public realm that we are inserted. And each big project defines like an approach to infrastructure that needs to assume that all the water, the runoff conditions of these neighborhoods can be kind of collected and retained in these kind of pools that they design. And the state of them are very kind of sad in a way. So we design like a system of public spaces. I'm gonna just be showing this one. That is the retention elements that is the same that I showed before, but trying to make something different. It has a lot of restrictions, as you see here, all the outlets, so the water just come here and start kind of flooding this area. There are small spaces that we try against to build with the same workers there, welding steel pipes, etc. But this is the area that you can see it has like a border that have all the runoff conditions of the neighborhood. Defines again like vegetation profile, almost like a deserted one. All these are kind of the lines where the water runoff conditions runs here. And we were trying to start providing like shade too. I think it's something that is not related to water in itself, but it's totally crucial for us now. And we were trying to create like this kind of playground with shade that's supposed to be like a lot of vines coming here. But the owner, the developer, thought that it was much more intelligent to have something of plastic here before, and in 1 week they have the shade. That happened when we were here, but this is kind of what we have been doing for parking lots, etc. too. So I think we are going to try to fight back to get the planting done soon. This is, I think, a small project that is going to run fast. That is not in Santiago, but it has to do with flooding, where they gave us like 1 week to have like one scheme. It was just as a mock-up they told us, but then we realized that it was like almost gonna get built soon. And and we just focus instead of the design in a profile for flooding areas. As I said before, this is an area of a lot of wetland in Valdivia. That is like everything is almost like a wetland condition. So the neighborhoods are historically being associated with this very wet condition of the urban realm. And we just design almost like one profile. It's a detail. We try to change every profile of what the engineers were doing, and try to test if, and this is going to get built soon, I guess, try to test how to think about floodable areas to manage stormwater with the species that they are kind of flood tolerant. And it's a matrix of different species that we're almost testing. We don't have so much knowledge. We work with ecologists, etc. But this is much more an innovation for I would say for Chile. And going down, and this is the last scale that I would like to talk about. This is like a workshop that we did in Buenos Aires in the Barrio 31. It's the biggest informal settlement of Buenos Aires, where 40,000 people lives. And we were doing like trying to understand in this notion of informality, how to learn from it and try to understand possible solutions to deal with water. There is no, as you can see, nothing about like infiltration areas, etc. This is just one house on top of the other, almost like 6 or sometimes 4 to 6 stories, and where sometimes you have like now renovation projects like these ones. But the problem of the water is like this is almost like a concrete basin. So all the water that get collected here needs to be somewhere. And the workshop seeks to answer the question about how to think about an intervention of spaces that had been conceived from informality, but today are presented as a part of the consolidated city. This is kind of what the World Bank, the IDB, all the local government says. There is not going to be eradication of informality. We need to eradicate it. So we need to transform something that was very organic and very bad in certain standards to a normal city. So we were working with prototypes, and this was like maybe a link between professional practice and students, to have like people from the neighborhood, professionals from the city, family members, etc., working together to in 5 days design like solutions and design. This is like a worker from there, like a neighborhood that knows how to deal welding, etc., and try to define solutions to deal with water in this case. The water usually in Barrio 31 comes like in a very humid city in big amounts in a few hours. So we were working to provide solutions, not just for the protection of the certain local and of owners, but at the same time try to respond as an inquiry that the neighbor has, like how to collect water in the rooftop, and to provide as a way to define and develop like landscape typologies on top of their houses. What I think is interesting about this is like what I've been doing at the school here is trying to provide this view of multiple, kind of a multi-scholar approach to pedagogy, and try to help to give the students like certain tools to think in both scales. So I'm going to show just a few images of what some students in Core 4 or in the seminar that I've been teaching, they have been doing. This is Zoe Hicks. He worked in the Core 4 studio, like a project in the Tobin Bridge, almost transforming like a big piece of infrastructure into a water catchment area, where the scale, there are multiple scales. This is the previous one was the scale of the highway, and this one is the scale of kind of the prototype, almost like the last project that I was showing. And I guess that the students are great in that sense, that they are much more malleable than sometimes we are, and they're working in different approaches to define not just like kind of the big scope problem, but at the same time, what is the implementation of certain solutions. Elaine Smuda, Slow Water, again, is in Charleston, trying to deal with like small catchment areas at the neighborhood scale, but always like thinking that this kind of a scale is pretty important. I think that in the case of Batuco wetland or the Barrio 31 that I just showed, I think we need to be able to define this scale of definition and to resolve issues that they are much bigger. Gracie Meek, the final project of the Core 4, again, coming from a kind of an adaptation strategy for climate change in Charleston to the scale of something that is pretty, I guess, sensible in a way, but I think put again design in front of the conversation. And this is the last part, that is like the seminar that I've been teaching, that's called Public Drawing. That is, again, kind of exposing students as a way to understand that even though in informality, and we were working here in Asunción, Paraguay, in the Chacarita Alta, it's an informal settlement that we are working with the IDB, they can perfectly are able to understand the scale of the problem that they have and how the water operates here, but at the same time how they can respond to specific definitions and problems with design kind of proposals. And this, sorry, I didn't mention Suyen Fan, and this is Florencia Lima working in a just piece of, kind of, I would say, a street that is very narrow, 6 meters wide, and how to transform water coming from the different houses into a space, a public space that is a new typology, that I think is a typology that we're going to be dealing in many, many cases in South America and in the global South. So this is kind of my trip for the GSC, but at the same time, maybe a way to link back together all what I've been doing and what I've been thinking. And I guess it's interesting because at some point I heard once someone at the GSC saying that there are two types of faculty here, the practitioners and the curators. And I think that I would say that I believe in both, mixed, combined, complemented, with blurry boundaries, even for ask ourselves where should we position if we need to take certain kind of final definitions. And I think that for my perspective in the professional life that I do and in the pedagogy, I would say that we need to locate in the best possible positions to produce change in the way we build a urban landscape, or what we call in Santiago the paisajes urbanos. So thank you. Yeah.
Thank you, Tomás. It's very enlightening to see the scale of your work go from, I was going to say the region, but the continent is a better word. The continent, to the paver and to the puddle. Do you imagine that this private ownership of water will ever change in Chile?
We are in a process since 2019 of changing the constitution in Chile. The water code has been is in the Congress. It's already changed. It's defining certain kind of rigidities still, but I think it's going to change. But I'm not sure yet how that is going to be implemented, because they say, yeah, we can change the code, we can be much more strict in the use of water. But I think it is still this image that for me, when I was trying to start the elaboration of this presentation, I just realized that no matter what water code we have, we just need to have like another positions to it. I think we need to have another positions to water. We need to adapt to a scenario that's going to be totally different, where having water rights or not having water rights at all could be much better than we have today. But my personal kind of statement here is like, we're just gonna have water in a certain month, and so we're gonna be like a totally different society. And this is not that I think that I am kind of a regional kind of designer of that scale, but when I try to see all the countries that they are in the Andean region, they all are suffering the same way. So, and there are cities like Quito, Lima, and Peru, and in Ecuador, in Chile, they're all going to be facing the same way. And it's amazingly how clear for me is that we need to have this territorial approach and at the same time like this design approach to projects, while we are not having like a professional degree of landscape architecture in South America. So yeah, I guess from that question I would say that we need to advocate for the change of that water, but I think we need to have like a much more bold approach to adapt the existing condition of our cities in South America. Maybe that is going to be way beyond the limits of a water code.
So it seems very extreme to think of access to water being controlled in private hands. It just seems extreme. Your formulation of the paradox of abundance and scarcity is also very clear. It's an odd juxtaposition. You think, my God, this is probably going to be even more so true in years ahead. What about the dissemination of your work? I mean, I had this question for a good part of your talk. There's a sensibility that really has to be shared. And then you showed the workshop, which is probably a pretty effective way to reach, this many people. But how about reaching a bigger audience?
Mm-hmm. Yeah, I think I have the clarity that I need to do it. Maybe coming here has helped me to see that this kind of imposter syndrome that some people have maybe need to be at some point just erased, because we are very. I think that it's a bad position from a personal kind of professional career to say, no, I need to wait till someone come and knock and discover me. And I say like, yeah, if we are doing certain work, it's important to share it. And maybe I think that the fellowship has been a great platform. In Chile, it's important to be in Harvard. So this is opening certain kind of doors to start not just necessarily disseminating, but maybe doing the same work in a bigger scale. And that is something that we need to do more. We need to learn more how to do it. But at the same time, we just need to put ourselves in the position that we can make mistakes. We can maybe be wrong in certain moments, but we shouldn't be shy or kind of timid about like working at this scale. So yeah, maybe that is something that is a much more a personal reflection of, but I'm trying to change it and say, well, yeah, maybe there is things that they are relevant to communicate.
Well, you're modest, but you also now have pedigree, right? Maybe this will change. The messenger has pedigree. Do others have questions? I gave you a chance to think about it.
Hi, Tomás. Thank you very much for the presentation. I really like the maps that you showed of the city of Santiago with all the data about the different moments in which water or the rights of water. And I was, in a way, I don't know, this more than a question is maybe sharing a thought and see what your reaction is. I was missing kind of I would love you to work on something that I was missing, which is this kind of synthetic drawing that you began the presentation with, no? Like the idea of the water cycle. Mm-hmm. You know, how the energy contained in the sun puts the atmosphere in motion, and the water, it's evaporated, and then it's precipitated, and then the energy contained in the earth, which gives shapes to the crust of the earth, curates the process by which the water goes back into the ocean. So, when you begin to talk about it seems like almost like a drawing that could emerge very easily from this work, no? Where we see the Andes, and the water cycle represented in the valley in which Santiago sits, where the movement of water is not just curated by the energy of the sun and the energy of the earth, but also by technology, by all the different interventions that humans have provided in order to curate that flow of water in a different way. So this is kind of the provocation, I would love to see that drawing at some point. I would like to make that drawing myself, maybe. But so if I want to turn this into a question, for example, when I see the towers, the water towers that seem to exist on the western side of the city, where the gravitation has lost this gravitational energy has been lost, how are those water towers filled today, or how were they filled in the past? By mechanical pumping, or using the gravitational force of the valley, of the water running down the valley to fill them up? So I don't know, this, I guess it's a provocation and then a very specific question around the same.
From the first point, I think that we need to do it. I think this is maps. When I just came here, like at noon, I was like, we have a problem with the curtains. Say like, yeah, we're not going to show the maps so good. And maybe there is a lot of detail that is trying to be part. I use the time of the fellowship to end up this research, and this is going to be like a studio report complementing. Again, I was like, no, I shouldn't do like a studio report. But then I say, no, I need to do it. I need to show what we have been working on. And I guess that this is like a great suggestion. And there is a need of certain synthetic elements to communicate something that needs to be clear. Maybe we spend so much time trying to get like the files from the government and then trying to start looking about where these points landed, etc. But I think that is like a super good suggestion. And about the infrastructure, I guess that is like, yeah, we worked that in the Option Studio in 2019, because all these sites were developed when the water was a public mean, and so there was like a public entity called Empresa Nacional of Water, so the National Company of Water, and then was privatized and it was sold to kind of first Spanish companies, now French companies. And those sites were huge because they were like a state sites. So there were like 17,000 square meters. So there is in a kind of a urban grid that is very compressed, So there are almost 200 points in the city distributed, almost like in the same way as in Medellin, where you have like these unidades vecinales. The same one, because it's trying to create like a grid of distributed point where the water comes, they need to pump it 25 meters, so they put it there. And then it works gravitational to distribute to maybe 5,000 people. And so it's like very beautiful, the diagram, because it's like one point with the 25 column meters of water distribute and then create like an array of different points. And that is, today they're just using 5% of the surface of those sites. And we have been trying to work with, at that point, with the company called Aguas Andinas to start opening. And maybe now that we started working again with this research, we have been talking with them again to say, well, maybe this could be like a national kind of agenda for kind of pushing up the level of the public realm in all this city, that at the same time kind of match perfectly with the water towers with the kind of low of medium income in Santiago. So maybe that is a public kind of agenda that we would like to push forward. But the drawing is like a super good suggestion.
Tomás, thank you. It's great to be back and know that Pablo is going to draw for you and you're becoming mayor of Chile to really solve the thing. So this is really great, kind of exciting moment for me. But now on a more serious note, I mean, the part I get from what you share with us today is that at the end of the day, it's also a kind of, it seems to be a problem of design, right? I mean, it's not that there is not enough water there, apart from, climate change and all these kind of like pressures. But it seems that if somebody would give you the leverage, the kind of, I would say, political, financial leverage, there is a solution, no? That involves, obviously, landscape restructuring, changing patterns of urbanization, activating these regulatory levers, right? That, rights and codes for related for water. But I don't know. I mean, I have a kind of both pessimistic and optimistic kind of feedback from the lecture, in the sense that it's true that the situation is not good and it's going to change quite a lot. At the same moment, it seems that everything is not yet lost, no? I mean, there is a way that if policy is implemented in the right way, design, supports, and massive reorganization of all these kind of like processes, it could be an interesting kind of way out. Is that a fair reading, or shall I stick to the more kind of pessimistic outcome?
No, I would. I think I put the water cycle, that new water cycle of the USGS there, because it's much more advanced in the way that designer thinks. They are saying us that we need to complement and overlap and create these kind of conflicting relations to create like a new agendas for design. I'm an advocate of design in that sense, and I think that examples like the Batuco kind of wetland recovery related to a kind of sewage treatment plant is like a great example. It was not that we didn't propose that. It would be great. I would be the mayor of Santiago if I the one to say, well, we need to use sewage treatment plant and to recover like ecosystem. But now that it's happening, I would just go, as Paulo said about the drawing, I would just go to that USGS diagram and say, well, what are all the relations that we can create with water today, to not be pessimistic, but to say that we need to be designers again. I guess that we sometimes, when we see these problems, and maybe that has happened before with the first part of the lecture, we stay in that scale of the territorial kind of mapping and say, well, this is the problem that we have. It's huge, so we can write about these critical problems. But I like the idea of saying that it's our responsibility to tackle the design component. And that is something that, with the students too, I think that is like a good kind of way to think. And I'm super glad of being teaching with Pablo in Core 1 and Core 4 with Lorena, that we are thinking, and Gary has been very clear about it, we need to think in design terms. We need to be, again, the ones that deals with these elements. And we have the tools, and we shouldn't like just avoid them because the problems are huge. I think we need to be very intelligent and theoretically speaking to define these big kind of constituencies and problems. But at the same time, our tools and our toolkit is about like design, and we need to be able to recover them and be bold and innovative in order to be not just pessimistic, but to create these new synergies about all these processes.
Thank you, Tomás, for the lecture. It's amazing to see your work. It's the first time that I see it, so it's a real pleasure. Please bring your modesty down and bring your talent up. I think it will be like super good for Chile, together with Sofia. I think there is something that I would like to really value from the work, which is the level of precision that you are using to design a very ambiguous realm, because, as Gary was saying, it's not really well defined in the country. But somehow, in your lecture, it is really wonderful to see that it is an engineering approach through design drawing, with a lot of creativity in recalibrating the way in which the infrastructure of water is being thought today. Mm-hmm. And I think that I really see a lot of value. For instance, you mentioned that at the level of 1,000 in Santiago, you cannot build on top of it. So I think, to me, there is like a hopeful lesson on how governance could actually start to change the way in which the territory is being like not really well used, but actually discarded, as in the example that you saw of that very low density urbanization on top of the clay territory. And the idea that somehow the public space needs to be amplified, as you are starting to do, with all the different ways in which water needs to be recycled and reused and recirculated. I see a lot of potential at all the different scales that you are talking. It's like how infrastructure is multi-layer and not unilayer as an engineering approach. So I see that there is the potential of the fusion between engineering and landscape that could bring this to like new realms for design. Mm-hmm. So
no, that's great comment. And actually, I didn't talk about the teams that are behind all this project, but we are very close to engineers now, and we are in the last project of Valdivia that engineers told us like, you have 1 weekend to give me the plan, and if not, you're out. And said, well, okay, we're gonna do it, no worries. And then I think that they are much more open, sometimes like the disciplines of design in Chile, to start understanding like what landscape architecture can do in terms of infrastructure and kind of ecosystem services. I feel that we are called, and maybe after coming from the GSD 10 years ago, maybe that happened to a lot of friends coming to South America, we are called the paisajistas, like paisagistas, like almost like pejorative way of saying, yeah, you deal with flowers and plants. And at some point, we are trying to reinvent ourselves too, to say, well, yeah, we are that, and we are not ashamed of doing it. We are trying to learn much more about it, but at the same time, we are kind of urbanists of the landscape, and we work in that, and maybe we have been addressed in a much more positive way for engineers, that they almost understand the systemic view. They don't care about how the things look like. They say, well, no, whatever you want, but I want to work. I want to operate this park as like a water system. So if that works for us, it's okay. And in that sense, we see like an opportunity to define like a required like professional degree. Instead of just saying we need to go and knock the door of a school of architecture to say we need a degree, we're just creating the needs, and we are creating some situation that at some points will force things on the table. And we are trying to not grab like a lot of that space, but at least to say that we can help others to maybe start opening that field of professional degree.
That's very exciting what you said. I think you have to demonstrate it, and people will listen. Thanks, Matt, to your team. Thanks, Paige and Raquel. Thank you all for coming. Tomás, thank you for your lecture today, but also for your amazing way of being a colleague.
Thank you, Gary.